Now we are moving on Module 5. Module 5, which consists of the following topic: design flood and estimation of design flood having four methods: catchment runoff method, empirical formula method, rational method, cross-sectional area and bed slope method, flood frequency analysis by using Gumbel's method. In this video, we are discussing about design flood and the different methods to estimate the design flood. What is design flood? The design flood is the maximum flood to withstand by an engineering structures, or in other words, it is the maximum flow that could be passed without damage the stability of engineering structures. For estimating the design flood, we have four methods. The first one, catchment runoff method. In this method, mainly we are discussing the relationship between catchment and runoff. Before that, the catchment area is the total area or watershed area, is the command area of a river where from the river gets the supply of water, and the runoff is defined as the overflow of rainfall. That is already we studied in previous chapter. The estimation of maximum flood shall be based on the maximum recorded rainfall. The mainly runoff is depends upon the following factors such as porosity of soil, degree of saturation, vegetation, etc. And the percentage of runoff varies from 20 to 70% depending upon the shape and nature of the catchment. Second method is by using empirical formula we can calculate the design flood. In this method we have three formulas. First one, Dickens formula. Here Q is equal to C into A power 3 by 4, where Q is the maximum flood discharge, that is in meter cube per second. A is the area of catchment, that is in kilometer square, and C is the coefficient, the values varies 11 to 22. The next formula, Rives formula. Here Q is equal to C into A power 2 by 3, where Q and R same as in Dickens formula, and C is the coefficient, the values changing from 25 km to 6.8 to 10. Then third formula, Inclis formula. This formula mainly used in the state of Maharashtra. Depending upon the areas, the equations will be changed. For small areas, Q is equal to 125 root A. And for all types of catchment, we are using the equation is Q is equal to 125A divided by root of A plus 10. Next, third method, rational method. Here R is the total rainfall in centimeter and T is the time duration in hours, and I is the intensity of rainfall centimeter per hour. Then the equation will be I is equal to R by T. Also, the time of concentration is include this equation. That is, it's defined as the time taken by the runoff to reach the bridge site from the critical point. The time of concentration mainly depends upon length, slope and the roughness of the catchment, and the equation will be Tc is equal to 0.89 L cube divided by H whole power 0.385, where Tc is the concentration time in hours, H is the fall in level from the critical point, L is the distance from the critical point, and the values of H and L can be found from the contour map of the catchment area. Then the last method, cross-sectional area and bed slope method. We all know Q is equal to A into V, that is discharge is equal to area into velocity. Here velocity is derived from Manning's formula. So velocity is equal to 1.4858 divided by n into r power 2 by 3 into s power 1 by 2. Therefore, Q, that is design flood or peak discharge, is equal to A into that corresponding velocity. Here where R is the hydraulic mean depth and S is the bed slope. Thank you.